A continuous graph is a graph that's unbroken, like this picture right here. It's a solid line of any kind. A discrete graph consists of distinct isolated points, as in this graph right here. A function, which we've been talking about in different ways with rules, is a set of ordered pairs where the first element, which is the input, has a unique second element, which is the output. So remember, ordered pairs would look something along those lines. When you write an ordered pair, you want to make sure you put a parentheses around it. Otherwise, it's just two numbers. The set of input elements, or x values, is called the domain. And the set of all the output elements, or the y values, is called the range. The domain and range can be determined from the graph of a function by looking at the highest and lowest values for each variable, if there are highest and lowest values. So we're going to look through at some examples that are all just a little bit different. In this first set of examples, example 1, you can see that we have isolated points in all three of these examples, A, B, and C. So we're going to say that these graphs are discrete graphs. So in order to identify the domain and range, we need to decide what the input, which are the x values, are, and what the output is, which are the y values. So you can go through, and in each of these points has an x and a y associated with it. So this first one, I'm going to list them. It appears that the first one has a -4, 1. The second point is -2, up 0. The third point's over 0, down 1. Then I have the fourth point, which is 2, -2. So my domain would be the set of all the x values, which are the first ones. So I'm going to write it this way. I'm going to write it as a set using those squiggly lines here. And I'm going to name them. I'm going to say that this is x. And I'm going to draw a straight line. And this straight line in this situation is read such that. And so x such that x is equal to, and I'm going to list these x values, -4, -2, 0, and 2. And I'll finish my squiggle there. Then for the range, I'm going to write all the y values. So I'm going to say y such that y is equal to, and now I'm going to list all the y values here. Maybe I'll put them in order, so it's going to be -2, -1, 0, and 1. If any of those ever repeat, then I'm not going to write it twice. In example C, let's skip on over and do example C. We can look, and you don't really have to list these all out this way, but if it helps you, you can do it. So the domain for this last one would be x such that x is equal to, well, the first x value, see, here's my first point. Its x is a 0. This x is 1. This x is 2, 3, 4. So x, 1, 2, 3, and 4. And then for my range, which will be all the y values, such that y is equal to, well, for this point has a y value of 3. This point has a y. They all have y values of 3. So y is just a 3. I'll come back and let's come back to B. So let's again go through, and then for our x's, we'll have x such that x is equal to, this first point has an x value of -2. The second one has an x value of -1. The third one has an x value of 0, then 1, and 2. And the y values, the first one has a y value of 1, 2, 3. The second one has a y value of 0. and the third one has a y value of -1. The fourth one, I have a y value of 0 again, so I don't need to repeat it. And the fifth one has a y value of 3 again, so I do not need to repeat that.